Hello, this is Scholar Strive doing some math. Today in Algebra 1, this is Unit 2.1. This probably be Chapter 3 in that red kayak book. Um, Actually, I don't think it is in Chapter 3. I don't know what this is. But we're going to do this before we start Chapter 3, and let's go over the distributive property. The product of a number n and a sum is equal to the sum of each added multiplied by n. So basically what they're doing here is we have a number times a sum here. And what you want to do, is I like to, so this is the distributive property. I like to use rainbows. Look bad. And basically what's going to happen is I'm going to take A and multiply to B, and then I'm going to take A, multiply to C, and then add them together. If we have A times the quantity B minus C, we're still going to multiply A and B together and A to C together, but this time there's a subtraction. And if all these symbols are confusing you, don't worry, there's some examples below. So term. Terms are the parts of an expression that are added together. So here, let's just do an example here. Let's put some random stuff here. So these would be the terms, the things that are being added or subtracted together. So the 3x would be a term, the 2y would be a term, and the minus 1 would be a term. Coefficients are the numbers in front of the variable. So that's a coefficient. And then same with this 2 in front of the 2y. A constant term is this negative 1 here. And constant term has no variable. It's just a number. So that's a constant. Okay? So when we have an expression, we have terms being added or subtracted together. The coefficients are the numbers in front of our variable, usually x or y. So the number in front of it. The constant is a term with no variable, so no letters. Okay. And then like terms are terms that have the same variable parts. So these are like terms, like 3x plus 2x. They're like terms because they both involve just an x, right? And then these would be an example of not like terms. And let's say 3x and 2y. These are not like terms because one's x, one's y. Equivalent expressions are two expressions that have the same value for all values of the variable. If you substitute, basically if you have two equations and you substitute a number in, it works for both. And we'll go over an example on that later. So let's go back to the distributive property. Okay. So algebra, just looking at letters here. A times B, A times C. So AC. And and it doesn't matter how you write it. Normally, I prefer you to write the outside number on the left side, not on the right. A times the quantity B minus C, you still do that, and you do that. All right, let's use some actual numbers. So 4 times 2 plus 4 times 3. Okay, so why are we learning this when we can just do the parentheses 2 plus 3, and that's 5, and then times it by 4 to get 20? So the reason why we're learning this, because they're not always going to give us the numbers. There's going to be letters in there, variables. So let's continue on. So that's why we're working this out. This is how you kind of show your work. So this would be 3 times 2 and 5 times 2. Okay. 7 times 5 minus 7 times 3. Six times 9 minus 4 times 9. And then the left side of this equation and the right side of this equation are considered equivalent expressions. You'll get the same answer. Well, if they had a variable, they would have the same answer. Okay, let's do more stuff. Alright, here we go. Use the distributive property to write an equivalent expression. So I'm going to use the distributive property to make my rainbows. So that means 4a plus 4 times 3. So 4 times a is just 4a. And then 4 times 3 is 12. And then we're done. This would be 6a plus 5 times 6, which is 6a plus 30. 3 times x is 3x, minus 3 times 8, which is 3x minus 24. So I said we just leave it like this, and the reason because we don't know what a is, or x, we don't know what the variable is. So we cannot add these terms together. These terms on the right are constant terms. So the constant terms are 12, 30, negative 24. And then 4a, 6a, 3x, those are just other terms with a variable. Okay. Okay, this one is a little bit tricky. So this is x times x. X times x is x squared minus 4x. Okay. So these are not like terms. You cannot add or subtract them together. Okay. The x squared terms, think of them as squares. And then think of x's as rectangles. Can't add them together. or you can't add them together evenly. Alright, use the distributive property to do some more. Here we go. 1 second. Okay. So this is negative 3 times x. So let me write that out. Negative 3 times x plus negative 3 times 7. So that would be negative 3x minus 21. Or plus a negative 21. Okay. Okay. So this one, negative 2a, so we have 6 times negative 2a. And then negative, or we have minus a times negative 2a. Okay. So I'm just going to multiply the numbers together. So this is negative 12a. Here, I have a negative sign. So this is negative a times negative 2a. So I have two negatives. Remember, that becomes positive. So whatever that is multiplied out to be, it's going to be positive. And then there's the 2. And then a times a is a squared. Okay. Negative 3 times n, negative 3 times 4. So that would be negative 3n plus a negative 3 times 4, which will be negative 3n minus 12. Negative 3a plus negative a times a, which is negative 3a plus a squared, or minus a squared. Because negative a times a is negative, a times a is squared. Okay. So they want me to try color coding. Okay. So simplify the expression by combining like terms. Okay. So remember, like terms are, well, they look alike. So let me use a color here, red. So these are my y terms, or those look alike. Okay. So we have 7y minus 4y is 3y. Think of it as 7 apples minus 4 apples is 3 apples, which y would be the apples. Okay. And then let's use a different color. Green. So we have negative 11 and negative minus 1. Okay. So we have negative 11 minus 1. And let me rewrite, so that would be negative 12. And then let me rewrite this one. This is 7y minus 4y, which is 3y. Okay, so my answer (3y minus 12). Okay. All right. So let's move on here. So I have negative 6x. I have positive 8x. I have a plus 10x. Okay. So I have negative 6x plus 8x plus 10x. So negative 6 plus 8 is 2. Positive 2. Plus another 10 is 12x. Okay. And then we have a positive 7y, positive 9y, and a minus 11y. So 7y plus 9y minus 11y. 7 plus 9 is 16, minus 11 is 5. And it turns out to be positive, so plus 5y. Okay, and that will be our answer. Okay. Simplify the expression by combining like terms. Okay, now I'm going to do it without colors. So this one has an A, that one has an A. I have 3A minus 6A. And then my constant terms, 10 minus 4. So remember, constant has no no variables, no letters. So 3A minus 6A is negative 3A. And then 10 minus 4 is positive 6. Okay. Now what if we have... So here's another example. So what if we have 3x plus 5y minus y plus 2x squared? Okay. So our like terms are only just 5y and minus y. Okay. So 5y minus y is 4y. The x and the x squared, the x squared are not the same. So we're just going to add them. Okay? And that would be the most simplified form. So x's and x squareds are different. Y's and y squareds are different. X cubes are different than x squareds. So the exponent makes it different. Okay? Think of x squareds as a square block. Think of x's as like a skinny rectangle. And then think of constants as just like a tiny block. Kind of like ones, tens, and hundreds, if you want to think of it like that. We can only add our x squared terms together. We can only add our y's together, or subtract, or x's. We can multiply. X squared times x is x cubed, remember. But adding some, when we're adding, subtracting, we can only add like or subtract like terms. All right, that's it for section 2.1. Not section 2.1, unit 2.1, and that's it. Have a good day.